Good morning students. Today topic is trigonometry identity usage. Recall the trigonometric identities. Number 1, sin square theta plus cos square theta is equal to 1. Number 2, secant square theta minus tan square theta is equal to 1. Number 3, cosecant square theta minus cot square theta is equal to 1. These are the trigonometric identities. Now, EX number 3.1 continuation. Sum number 6. If y is equal to 2 sin alpha divided by 1 plus cos alpha plus sin alpha, then prove that 1 minus cos alpha plus sin alpha divided by 1 plus sin alpha is equal to y. Let y is equal to 2 sin alpha divided by 1 plus cos alpha plus sin alpha. Multiply numerator and denominator by 1 plus sin alpha minus cos alpha. Cancelling these two, we get the original previous one. Now 2 sin alpha into numerator, 2 sin alpha into 1 plus sin alpha minus cos alpha whole divided by denominator 1 plus sin alpha, 1 plus sin alpha plus cos alpha into 1 plus sin alpha minus cos alpha. So a plus b into a minus b model. A plus b into a minus b model is a square minus b square is equal to a plus b into a minus b. Using this, we get 1 plus sin alpha whole square minus cos square alpha is equal to a plus b into a minus b model. Cos square alpha can be written in the form of 1 minus sin square alpha. 1 means 1 square. 1 square minus sin square alpha is 1 plus sin alpha into 1 minus sin alpha. Numerator as it is. Denominator cos square alpha is equal to 1 minus sin square alpha. 1 means 1 square minus sin square alpha, a plus b into a minus b model. Now denominator common 1 plus sin alpha. Remaining part 1 plus sin alpha minus 1 minus sin alpha. Cancelling we get sin alpha plus sin alpha is 2 sin alpha. Numerator 2 sin alpha, denominator 2 sin alpha. Cancelling we get 1 plus sin alpha minus cos alpha divided by 1 plus sin alpha. Can be written as 1 minus cos alpha plus sin alpha whole divided by 1 plus sin alpha, hence proved. Next, sum number 8. Sum number 8. If tan square theta is equal to 1 minus k square, so that secant theta plus tan cube theta cosecant theta is equal to 2 minus k square whole to the power of 3 by 2. Also find the value of k, for which this result holds. Let tan square theta is equal to 1 minus k square given. If condition will be taken. Add 1 on both sides, we get 1 plus tan square theta is equal to 1 plus 1 minus k square. 1 plus 1 is 2. 2 minus k square. We know that secant square theta minus tan square theta is equal to 1. Trigonometric identity. Using this, 1 plus tan square theta is equal to secant square theta is equal to 2 minus k square. Raising the power 3 by 2, on both sides we have secant square theta whole to the power of 3 by 2 is equal to 2 minus k square whole to the power of 3 by 2. 2 cancelled, power 3. So secant power 3 theta is equal to 2 minus k square whole to the power of 3 by 2. Secant power 3 theta can be written in the form of secant theta into secant square theta. Power 1, power 2. So totally adding the power we get secant power 3 theta. Okay, secant theta into secant square theta is equal to 2 minus k square power 3 by 2. Now secant theta, secant square theta, using the identity secant square theta is 1 plus tan square theta is equal to 2 minus k square whole to the power of 3 by 2. Now 1 plus tan square theta multiplied by secant theta, we get secant theta into 1 is secant theta into tan square theta is secant theta tan square theta is equal to right hand side. Secant theta, this secant theta can be written in the form of 1 by cos theta. Tan square theta is sin square theta divided by cos theta. Multiply numerator and denominator by sin theta, we get sin power 3 theta cos power 3 theta into sin theta. This can be written as sin theta cancel, cos power 3 theta sin square theta plus secant theta is equal to, take LCM, we get secant theta plus tan theta. 1 by sin theta is cosecant theta, sin square theta by cos square theta is tan square theta is equal to 2 minus k square whole to the power of 3 by 2. Hence the result. Next, sum number 9. If secant theta plus tan theta is equal to p, obtain the value of secant theta, tan theta and sin theta in terms of p. Given secant theta plus tan theta is equal to p. By the trigonometric identity, secant square theta minus tan square theta is equal to 1. This can be written as a plus b into a minus b. Model a square minus b square is a plus b into a minus b is equal to 1. Secant theta plus tan square theta is given by p. So p into secant theta minus tan theta is equal to 1. Now divide through by p on both sides. We get secant theta minus tan theta is equal to 1 by p. Number is as 2. Given condition is 1. Now new condition is 2 from the given condition. Okay. Add 1 and 2. We get secant theta plus secant theta, 2 secant theta. Add equation number 1 and 2. Secant theta plus secant theta, tan theta minus tan theta is cancelled. Therefore 2 secant theta is equal to p plus 1 by p. Taking LCM on the RHS, we get p square plus 1 divided by p. Now divide through by 2 on both sides, we get secant theta is equal to p square plus 1 divided by 2p. Number this is 3. Take equation number 1 and 2, subtract 2 from 1, we get secant theta plus tan theta minus secant theta minus tan theta is equal to p minus 1 by p. Now first bracket, eliminating, we get secant theta plus tan theta. Distribute this negative sign, minus secant theta, minus of minus positive tan theta. Secant theta, negative sign of secant theta is cancelled. 2 tan theta is equal to p. Divide through by 2 on both sides, we get tan theta is equal to p square minus 1 divided by 2p. Equation number 4. Now take equation number 3 and 4. 4 divided by 3 gives tan theta divided by secant theta is equal to p square minus 1 divided by 2p whole divided by p square plus 1 divided by 2p. Denominator 2p cancelled. Tan theta can be written in the form of sin theta by cos theta whole divided by secant theta is 1 by cos theta. Denominator cos theta. So cancelling these two, we get sin theta divided by 1 is sin theta is equal to p square minus 1 divided by p square plus 1. Hence secant theta is equal to p square plus 1 divided by 2p. Tan theta is equal to p square minus 1 divided by p square plus 1. Next, sin theta is equal to p square minus 1 divided by p square plus 1. Okay. Now tan theta is p square minus 1 divided by 2p. That's important. Okay. If cosecant theta minus sin theta is equal to a to the power of 3 and secant theta minus cos theta is equal to p to the power of 3, then prove that a square b square into a square plus b square is equal to 1. Let cosecant theta minus sin theta is equal to a to the power of 3. Raising the power 1 by 3 on both sides, we get cosecant theta minus sin theta whole to the power of 1 by 3 is equal to a. This will imply a is equal to cosecant theta minus sin theta whole to the power of 1 by 3. Cosecant theta can be written in the form of 1 by sin theta minus sin theta whole to the power of 1 by 3. Taking LCM, we get 1 minus sin square theta divided by sin theta whole to the power of 1 by 3. We know that sin square theta plus cos square theta is equal to 1. In this case, 1 minus sin square theta is cos square theta. So cos square theta divided by sin theta whole to the power of 1 by 3. Okay. Next, second condition. Secant theta minus tan cos theta is equal to b to the power of 3 is given. Raising the power 1 by 3 on both sides, we have secant theta minus cos theta whole to the power of 1 by 3 is equal to p. This implies p is equal to secant theta minus cos theta whole to the power of 1 by 3. Secant theta can be written in the form of 1 by cos theta minus cos theta. Taking LCM, 1 minus cos square theta divided by cos theta whole to the power of 1 by 3. 1 minus cos square theta from the trigonometric identity sin square theta divided by cos theta whole to the power of 1 by 3. Now sin square theta divided by cos theta whole to the power of 1 by 3 is b. Okay. LHS equal to a square b square into a square plus b square to prove RHS 1. Okay. LHS a square b square a square plus a into a square plus a b square. A square. A is cos square theta divided by sin theta whole to the power of 1 by 3. Okay, a square means cos square theta divided by sin theta whole to the power of 1 by 3 into 2. So 2 by 3. Okay. Next b square. B square is sin square theta divided by cos theta whole to the power of 1 by 3 into power 2. Therefore sin square theta divided by cos theta power 2 into 1 by 3 is 2 by 3. Okay. Next bracket a square plus b square. Cos square theta divided by sin theta whole to the power of 2 by 3 plus sin square theta divided by cos theta whole to the power of 2 by 3. Now the first part, this can be written as 2 by 3 into 2 is 4 by 3 cos power 4 by 3 divided by sin power 2 by 3 into sin power 4 by 3 divided by cos power 2 by 3 theta. Okay. Now second bracket over. Next third bracket, taking LCM we get cos square power 2 by 3 means cos power 4 by 3. Taking LCM, here denominator cos power 2 by 3. So cross multiplying we get cos power 4 by 3 theta cos power 2 by 3 theta plus here denominator sin power 2 by 3, here numerator sin power 4 by 3 theta. So taking LCM we get sin power 4 by 3 theta sin power 2 by 3 theta whole divided by sin power 2 by 3 theta into cos power 2 by 3 theta. Okay. Now cancelling cos power 4 by 3 theta divided by cos power 2 by 3 into cos power 2 by 3 is cos power 4 by 3 theta. So this and this are cancelled. Next denominator sin power 4 sin theta whole to the power of 2 by 3 into sin theta whole to the power of 2 by 3 means sin power 4 by 3 theta. Here numerator sin power 4 by 3 theta, cancelling this. Remaining part this numerator only, cos power 4 by 3 theta into cos power 2 by 3 theta, cos theta cos theta. So powers are adding, we get cos theta power 4 by 3 plus 2 by 3 plus sin 4 by 3 theta sin theta 2 by 3 sin theta. So adding the power we get sin 4 by 3 plus 2 by 3 is 6 by 3. 6 by 3 means sin square theta. Cos power 6 by 3 means cos square theta. So cos square theta plus sin square theta by the trigonometric identity, answer is 1. This is RHS. So eliminate theta from the equation. A secant theta minus c tan theta is equal to b and b secant theta plus d tan theta is equal to c. Let us take first equation, a secant theta minus c tan theta is equal to b, equation number 1. Next b secant theta plus d tan theta is equal to c, number equals 2. Equation number 1 multiplied by b, we get a b secant theta. Equation number 1 multiplied by b, a b secant theta minus b c tan theta is equal to right hand side b into b is b square. Equation number 2 multiplied by a implies ab secant theta multiplied by ab secant theta plus ad tan theta is equal to ac. Subtracting, we get ab secant theta cancel. Remaining part minus bc tan theta minus ad tan theta common minus b plus ad of tan theta is equal to right hand side b square minus ac, b square minus ac. Multiply minus 1 on both sides, we have this side positive. So bc plus ad into tan theta is equal to change ac and b square. So ac minus b square. So tan theta is equal to ac minus b square divided by bc plus ad. Okay. Take equation number 1 multiply by d. We get ad secant theta minus cd tan theta is equal to bd. Okay. Multiply c by equation number 2. We have bc secant theta plus cd tan theta is equal to c into c is c square. Now adding these two equations, we get AD plus BC common secant theta. So AD plus BC secant theta. This and this are cancelled. We get BD plus C square. Okay, right hand side. Now secant theta is equal to BD plus C square whole divided by AD plus BC. By the trigonometric identity, secant square theta minus tan square theta is equal to 1. So secant square theta is BD plus C square whole divided by AD plus BC whole square minus tan theta is AC minus B square divided by BC plus AD whole square is equal to 1. Now BD plus C square whole square divided by AD plus BC whole square minus AC minus B square whole square divided by BC plus AD whole square is equal to 1. Now denominators are same. BC plus AD, BC plus AD whole square. Okay, so denominators are same. Therefore take LCM. We get BD plus C square whole square minus AC minus B square whole square is equal to whole divided by the denominator AD plus BC whole square is equal to 1. Now cross multiplying we get BD plus C square whole square minus AC minus B square whole square is equal to AD plus BC whole square. Now BD plus C square whole square is equal to this negative sign of AC minus BD goes to BD whole square. AC minus B square whole square goes to right hand side, we get AC minus positive AC minus B square whole square. Now BD plus C square can be written in the form of C square plus BD. Addition is an operation, therefore interchanging there is no changes. So C square plus BD whole square is equal to AD plus BC whole square plus AC minus B square whole square. So this line gives the elimination of theta. Hence the result. Now today homework, EX number 3.1, sum number 7 and 10. If any problem, reply the message.